We're moving on. Section 4.3, exponential modeling. Okay, so you got a job, you are a data analyst, you have some kind of data, and you have to figure out if this data linear or exponential. So at this time, you should know how to figure out and check if this data linear. So what do we do to figure out if the data is linear? Do you remember? It was on test number 2. You have to find out the average rate of change. And everybody knows how to do this. So for the first is not applicable. How will we find average rate of change here? Is 9.44 minus 5.9 over 2 minus 0. This is the formula y2 minus y1 over x2 minus x1. If you type everything nicely on a calculator, your answer will be 1.77. Okay, moving on. We have 11.21 minus 9.44 over 3 minus 2. Again, you have to know how to type it nicely or do it separately, numerator and denominator, but the answer will be again 1.77. But we have to keep going. We have 14.75 minus 11.21 over 5 minus 3 is equal to 1.77 again. And the last average average rate of change that we need to find out is 20.06 minus 14.75 over 8 minus 5. And again, it will be 1.77. What do you see? We see that all the average rate of change are the same. What does it mean? The data is linear. So let's say g of t is linear model. Let's find the equation. Again, there is nothing new here. Because it's linear, what equation will we use? I hope you remember y equal to mx plus b. Okay, what is my b? My b is initial value. Do you know the initial value here? Yes, it's given to us. It's 5.9. So 5.9 will be here. Do we know m? M is our slope. And when we talk about linear modeling, slope has the same name as average rate of change. And we know that all the average rates are the same. So our slope is 1.77x. You learned this already. You had a similar problem on test number 2. So you are good with this material. Here's new data. You see the table, and again we have to figure out if this data linear or exponential. And again we'll start with average rate of change. Let's calculate really quickly. 2.16 minus 1.5 over 2 minus 0 is 0.33. Next, 2.59 minus 2.16 over 3 minus 2 is equal to 0.43. And next one is 3.73 minus 2.59 over 5 minus 3 is equal to 0.57. So what would you say? Is this data linear or not? No, it's not linear because all the average rate of change are completely different. It's definitely not linear. Now we have to think, is this data exponential? How will we we'll find out? We need to find the factors. We need to find the factors, and again, the first one is not applicable. How will we find the factors? Probably you saw the formula already in PowerPoint and other places that I posted on Blackboard. So you have to memorize this formula or come up with something, your own idea or own formulas. To find the factor, the formula is y2 over y1 over to the power. It's a good idea to put parentheses here, especially if you have a TI-83 calculator, and parentheses right here, x2 minus x1, parentheses, and big parentheses here. And you have to learn how to type this formula on the calculator too. So, what do we have now? My y2 is 2.16 over y1 is 1.5 to the power 1 over 2 minus 0 inside of parentheses and parentheses. Now it's a good idea to stop my video and type this on a calculator and get the answer. I hope your answer is 1.2. If not, please review your typing. Probably you made a mistake in typing. Moving on. Next will be 2.59 over 2.16 to the power 1 over 3 minus 2. All this inside of parentheses. Again, type it, check it. Your answer is supposed to be 1.2. And the last factor, 3.73 over 2.59 to the power 1 over, parentheses here, 5 minus 3. And hopefully by this time you know how to type it correctly and you got your answer 1.2 right away. If you round it, you have to round to 1 decimal place in this case because in exponential model everything changes so fast. So what do you think? What kind of model is this? This is an exponential model. So in our case, it's function f. F of t is an exponential model. Now we have to find the equation of the exponential model. You always start with this, n equal to p times a to the t power. Do we know p? What is p? P is our initial value. Yes, we know because my t is 0 here. So this is my initial value. My p is 1.5. Do we know a? Yes, we calculated this already. Is 1.2. So the equation will be, and instead of n, you will use f of t. So the equation will be f of t equal to 1.5 times 1.2 to the t power. And show me big fat multiplication here. Here is the last problem from this section. The initial value of n is 12. If t increased by 9, the effect is to multiply n by 58. You know that I like tables because I like to make everything visual. So the initial value of n is 12, and my table will look like this, 0 and 12. Let's read the second sentence. If t increased by 9, in math, it will look like this, 0 plus 9. The effect is to multiply n by 58. It means whatever you had here before, you have to multiply by 58. So what is the point here? It is 0 and 12. What is the point here? Is 9. Multiply 12 by 58, it will be 696. We have 2 points. We have to memorize this beautiful formula. It's so easy to memorize, much easier than find a different way to find A. Let's use this formula. A is equal to 696 over 12 to the power 1 over 9 minus 0. You will get the answer, and you round your answer to 3 decimal places. So it will be 1.570 thousandths. So the equation is n equal to p times a to the t power. Do we know p? Yes, it's 12. Do we know a? Yes, it's 1.57. Don't forget to put t. Don't forget to put big multiplication here. So let's put everything together for this section. In this section, you learn how to figure out if the data linear or exponential. The other things you learn how to find the factor, how to use the formulas that you have to memorize, and how to find an equation of an exponential model using the formula. That's it.